Welcome back to our course, Network Theory and Transmission Lines. So in the last lecture, we have discussed about some basic concepts of the two-port networks and the applications of the two-port networks. So in today's lecture, we are going to discuss about the jet parameters. As we already introduced the jet parameters in the previous lecture. So today we are going to obtain the expressions for the jet parameters, and you are going to draw the equivalent circuit diagram of the from the jet parameter equations, and also we are going to solve some example problem. So these are the outcomes of our presentation. So where we are going to, by the end of this lecture, you are going to obtain the expressions for the different jet parameters, and you are going to know the equations of the jet parameters. Through the equations, you are going to obtain the equivalent circuit. And for your understanding, we are going to solve an example problem on obtaining the jet parameters. So coming to the jet parameters, as we said, in a two-port network, we are going to have four variables. So what are those four variables here? Four variables are V1, I1, V2 and I2. So in this, based upon these four variables, so two of the variables is going to be our dependent variables and the two other going to be our independent variables. So taking two at a time, we are going to have six combinations. So that means six different parameters you are going to have. So in that six parameters, one is the jet parameter. So this jet parameter is also known as the impedance parameter, and we can also call it as the open circuit impedance parameters. So why it is known as the open circuit impedance parameter, we will come across this one. And the unit for the jet parameters is nothing but the ohms. As the impedance, the unit for the impedance is ohms. So similarly, the same thing is going to be applied here. Also, so this impedance parameter is going to be widely used in the synthesis of different kinds of filters and also useful in the design of different impedance matching networks like transmission line networks. So different impedance matching networks, we are going to use this impedance parameter solutions, right? Especially in the power distribution networks, right? So let us obtain the jet parameter of a two-port network. For obtaining the jet parameters, let us consider the variables V1 and V2 as the dependent variables and I1 and I2 as the independent variables. So here, as we discussed in the previous lecture, the coefficients of the independent variables is going to be our parameters. So what are the independent variables here? I1 and I2 are independent in this case. So the coefficients of I1 and I2 is going to be your jet parameter expressions, the values of the jet parameters. So that means here, so again let us consider the same two-port network. We know that the general convention, that is V is equal to Z into I, where V is nothing but the voltage and Z is nothing but your impedance and I is nothing but your current. So in this, V is equal to Z into I is nothing but simply from the Ohm's law we can write V is equal to Z into I. So the same equation in the matrix form, if we want to represent, we can write the same equation as V is equal to Z into I. So here the Z is nothing but the square matrix and the Z is nothing but the square matrix and V is nothing but the column matrix and I also nothing but the column matrix. So from this, we can write where V is nothing but the column matrix. So because in this two-port network, we are having two variables, that is V1 and V2. So V1, V2. So Z11, Z12, Z21, Z22 is going to be our Z parameters. It's nothing but the square matrix. And I1 and I2 is going to be your column matrix, because we are having I1 and I2 are the variables. Here the independent variables are I1 and I2. So from this we can write the equations. V1 is equal to, if you multiply these two, Z11 into I1 plus Z12 into I2, and V2 is going to be equal to, right, what is V2? V2 is going to be equal to, with respect to the Z21 I1 plus Z22 into I2. So these are the Z parameter equations. So now the coefficients of these independent variables. What are the independent variables? I1, here also I1, and I2, and here also I2. These coefficients is going to be our Z parameters. That is nothing but Z11, Z12, Z21, and Z22. So these are nothing but your Z parameter values. So how to obtain this Z parameter value? So here, so the individual Z parameter values can be obtained for a given network using by considering the port currents equal to 0. So which port current should be considered to equal to 0? So now, for getting the values of Z11 and Z21 here, if you consider the port 2 is open circuit, the port 2 is open circuit, that means if the port 2 is open circuit, obviously the current I2 is going to be 0, because the current I2 is associated with the port 2 and the I1 is associated with the port 1 in a two-port network, right? So V1 is associated with the port 1 and V2 is associated with the port 2. So if you consider any one of the port is open circuit, that particular current is going to be equal to 0. So in this, so if you consider the port 2 is open, if the port 2 is open, the port 2 is open, that means the current I2 is going to be equal to 0. So if the current I2 is going to be equal to 0, from this equation, these are the Z parameter equations which we have obtained. So from this, if this is equal to 0 means, so this complete term is going to be equal to 0. So that means from this equation, what we can write? So Z11 is equal to V1 divided by I1. Z11 is equal to V1 divided by I1. So where here, how we have obtained? I2 is equal to 0. At I2 is equal to 0, we got Z11 is equal to V1 by I1. And this Z11 is nothing but the driving point impedance, or we can say it as the, so the Z11 is associated with the 1 means is nothing but the input port. 1 is nothing but the input port. So that is nothing but, it is nothing but the input impedance. So V by I is nothing but your impedance. Open circuit input impedance. So which one is open circuit? Port 2 is open. When we look into from port 1, the port is open. So from that equation, we came across Z11 is equal to V1 by I1. So which is nothing but, Z11 is nothing but your driving point impedance or open circuit input impedance, right? And similarly, same thing if we came across the other one from the second equation, that is from V2, if I2 is equal to 0 over here, so this complete term is going to be equal to 0. So that means from this we can come across Z21 is equal to V2 by I2, V2 by I1. So because I2 is equal to 0 here, this term is going to be completely equal to 0. So we can come across only this equation. So this portion is, if I2 is 0, this is going to be equal to 0. So that means here V2 is equal to Z21 into I1. From this we can write Z21 is equal to V2 by I1 at I2 is equal to 0. So Z21 is nothing but the transfer impedance. Z21 is nothing but the transfer impedance, or it is also known as the open circuit transfer impedance. As we are looking from the port 1, so it is nothing but the forward transfer impedance. It is nothing but the forward transfer impedance. So when port is open, so if we are looking from the two-port network, in the general convention is the input side, input port is, so if you consider a general convention of a two-port network, this is nothing but your input and this is nothing but your output. So if you look from this port 1, this is port 1 and this is port 2. If you look from this port 1, this is going to be the forward transfer impedance. Why it is transfer impedance? Because it is nothing but V2 by I1. The voltage is the V2 by I1. Output voltage to the input current. That is the reason why it is known as the transfer impedance. Right? So where I2 is equal to 0, we came across this one. So now let us consider I1 is equal to 0. If I1 is equal to 0, what we are going to come across? If I1 is equal to 0. If I1 is equal to 0, so here if I1 is equal to 0, from the first expression, what we can write? If I1 is equal to 0, this is going to be equal to 0. So that means V1 is going to be equal to Z12 into I2. So we can come across the value for Z12 is going to be equal to V1 divided by I2. V1 divided by I2. Right? V1 divided by I2. So Z12 is equal to V1 divided by I2 at I1 is equal to 0. When I1 is going to be equal to 0, the current I1 is going to be equal to 0. If this port, the current through the port 1 is 0, so that means if it is open, the current I1 is going to be equal to 0. This port is open. Open circuit means I1 is going to be equal to 0. The current is going to be equal to 0. If it is short circuit, voltage is going to be equal to 0. But here we are considering it as the open circuit. So because from the expressions of the Z parameter equations, we are considering to obtain this value, we have to consider this should be equal to 0. That means I1 is equal to 0 means the port 1 should be open circuit. Right? The port 1 is going to be open circuit. So from this value, we can come across Z12 is equal to V1 divided by I2. So where this Z12 is also a transfer impedance. This Z1 is also a transfer impedance, but here as it is also known as the, because we are open circuiting the port 1, so it is also known as the open circuit transfer impedance or open circuit reverse transfer impedance. Why? Because reverse transfer impedance, here the value of the Z1 is nothing but V1 divided by I2. So input voltage to the output current. So it is a reverse impedance. It is a reverse input voltage to the output current. Right? So reverse transfer impedance. So this is nothing but the reverse transfer impedance at port 2. If you look in from port 2, when the port 1 is open and the port 1 is open and the port 1 is open, we can come across the port 2, we can come across Z12 is equal to V1 by I2. And similarly, the other expression, if this one is considered as equal to 0, that means when the port 1 is open circuit, I1 is equal to 0. So this whole term is going to be equal to 0. So then we can come across V2 is equal to Z22 into I2. V2 is equal to Z22 into I2. V2 is equal to Z22 into I2. So that means here the Z22 is going to become V2 by I2. Z22 is going to become V2 by I2. So Z22 is going to V2 by I2 at I1 is equal to 0. That means the port 1 is open when we look from the port 2. When we look from port 2, the port 1 is open. So here, so Z22 is nothing but, again, it is nothing but the driving point impedance. It is nothing but the driving point impedance, or it is nothing but the open circuit impedance seen looking from port 2 when the port 1 is open circuit. So these values here is going to be our Z parameter values. These values is going to be our Z parameter values. Z11 is nothing but the driving point impedance or the open circuit input impedance, and this Z22 is nothing but also the driving point impedance, or we can say it as the open circuit output impedance. Open circuit output impedance. We can say it as the open circuit output impedance, and Z12 is nothing but the transfer impedance, or it is nothing but the open circuit reverse transfer impedance because it is V1 by I2. And this Z21 is also a transfer impedance, and it is also known as the open circuit forward transfer impedance. So these values is going to be our Z parameter values. So now let us draw the equivalent circuit for the obtained equations. So what could be the equivalent circuit? It's very simple. So if we look into the equations of the Z parameters, we know that V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. So from this we can write, so let us write the general two-port network convention circuit. So this is the equation. This is for the left side port. This is for the input port from when we look from the input side port, and this is from when we look from the port 2. So from this we can write V1 is equal to two voltage loop expressions. V1 is equal to I1 into Z11. So this is the Z11 is nothing but your impedance, and I1 is the current flowing through this. And here we are having a Z12 into I2. Z12 into I2, because the current associated with the input side is I1, but here we are having a I2 into Z12. So that is the reason why I have indicated using a voltage source. So this current is nothing but the Z12 into I2. Similarly, for this side, the second equation, this is corresponding to the first equation, and whereas this is going to be the second equation. So V2 is going to be equal to, this is the V2, is going to be equal to I2 into Z22. So here I2 into Z22, the current I2 and the resistance. Simply applying KVL. This is the KVL expression for this circuit. So I2 into Z22 plus Z21 into I1. Z21 into I1. So this is going to be our right hand side, the second equation loop expression, loop. So the overall circuit, if we combine this as a two-port side network, this is going to be our equivalent circuit diagram, right? So this is going to be our equivalent circuit diagram of the obtained equation, that is V1 and V2. So now let us solve some example. So in the example, so here the example is, the problem is here. So where they asked you to calculate the Z parameter of the circuit shown here. So it is a pie-shaped network over here. So in this network, where we are having again considering the regular two-port convention. So one is the I1 input side, and the voltage is V1. So this is the second port is from the second port. Let us consider this as the port 1, and this is the port 2. From the port 1, V1 and I1 are the variables, and I2 and V2 are the variables. So this is your network, pi network, where 3 resistors are there. So now for this, what we can have it here is, so here we can obtain the Z parameters using the two. We have to consider each of the port to be open circuit. So let us consider first the port 2 is open. The port 2 is open. So if we consider the port 2 is open, what's going to be our circuit? If the I2 is equal to 0, that means we are open circuiting the port 2. If you open circuit the port 2 for the given circuit, so this could be the equivalent circuit. This side is the port 2, this is the open circuit. That means the voltage is not going to be equal to 0, but the current I2 is going to be equal to 0. If the current I2 is going to be equal to 0, we don't know what is the current flowing through this loop, through this element. So that is the reason why I have considered the current through this element is nothing but the IA. IA is our current. And here in this loop, because if we want to say this is a series network, we can say the current is the complete network, the current is going to be the I1, but it is not a complete series network. In a two-port network, it is not easy to say whether it is in series or it is in a parallel. So if you consider these two is going to be in series, but whereas coming to this one and this one or this one and this one, we can't say it is in series or parallel. It depends upon the other one. So that is the reason why here I have considered the current as IB. So through the 120 ohm resistor, I am considering the current is IB here. So but here it is I1. So now from this equivalent circuit, so when we consider the I2 is equal to 0, this is going to be our circuit. So now from this, what I am going to do is, I am going to consider the voltage V1 is equal to, so V1 is nothing but the voltage across the resistor 120 ohm resistor. V1 is nothing but the voltage across the 120 ohm resistor. So this IB can be expressed in terms of I1 and as well as the IA, but here, but the voltage is going to be the potential, V1 is going to be the potential difference across the 120 ohm resistor. So V1 is equal to, I am writing it as 120 ohms into, what is the current here? What is the current here? IB. The current is IB. So now, when the current is IB here, 120 into IB. V1 is equal to 120 into IB. So now, I am writing the expression for IB. What could be the IB here? This is the current IB. This is the current IB. So now what I am going to do is, here I am going to apply the current division rule. So what the current division rule? The current division rule, when we want to find the current, so the current IB is going to be equal to the source current. What is the source current here? The source current is going to become I1. So I1 into opposite resistance. So this is our resistance, right? This current is IB. What could be the opposite resistance? These two are in series. So this two is going to be our series combination of these two resistance is going to be our opposite resistance. So 240 plus 40 is going to be 80. 280 divided by sum of the total resistances. So 240 plus 40 is going to be 280. So 280 plus 120 is going to become 400. So opposite resistance divided by sum of the resistances. So 280 divided by 400 into I1, the source current I1. So now let us consider this as the equation number 2 and the previous one V1 is equal to 120 into IB is going to be our equation number 1. So now substituting this equation number 1 in equation number 2. So what's going to happen here is, if you substitute the equation number 1 in equation number 2, so that is here, just we are substituting the value of IB. The value of IB. So what is the value of IB? The value of IB is going to become V1 by 120. V1 by 120. So from equation 1, we can substitute the value of IB as V1 divided by 120. So now this side we are having I1. If you bring this side, this I1, we are going to have V1 by I1 is going to be equal to 280 divided by 400 into this 120. So this is going to give the value that is nothing but 84 ohms. This is going to give the value 84 ohms. So we know that V1 by I1 is going to be our Z11, which is nothing but the driving point impedance looking from the port 1 when the port 2 is open circuit. Or we can say it as the open circuit input impedance. Z11 is nothing but the open circuit input impedance. Similarly, from this equation, let us write the equation for V2. So V2, we know that V2 is nothing but the voltage drop or the potential difference across the resistor of 240 ohms. So V2 is going to become 240 into the current I have considered here is IA. So V2 is going to become 240 into IA. So let us say this is the equation number 3. So from this, again, if I want to get the expression for IA is equal to, again applying the current division rule. So IA is going to be equal to the source current. This is the current IA. I am considering this as the current IA. So if I consider this as the current IA, what is the source current here? The source current here is I1. If you consider here the second one, if you consider here, because this is the open, the current I2 is going to be equal to 0. So the source current I1 into the opposite resistance, that is nothing but 120 ohms. So when we come across from this side, if we look from this port 2, that is when we are writing the potential difference across this 240 ohm resistor, as here it is the IA, the current IA is flowing through the 240 ohm resistor. We can't say what is the current flowing through the 120 ohm resistor, and we can't say what is the current flowing through the 40 ohm resistor. Now when we look from this side, we can't say the current from the 120 ohm resistor and the 40 ohm resistor is same. So that is the reason why these two is not going to be in series. So now as this is going to be the same here, so 240 ohm and 40 ohm is going to be come into the series. So now here this IA is going to be equal to the opposite resistance, that is nothing but 120 divided by the sum of the resistances, that is 240 plus 40, 280, 280 plus 120, 400. So 120 divided by 400 into I1. So let us say this is the equation number 4. So now substituting this equation number 4 in equation number 3. So now which is equal to Z21 is equal to V2 by I1. How we came across this V2 by I1 here? So that means, so now substituting this 4 in this one. So what is IA here? IA is nothing but 120 divided by 400. So now simply if you want to write V2 is equal to 240 into, what is IA from the equation number 4? IA is nothing but 120 divided by 400. 120 divided by 400 into I1. So now V2 by I1 is equal to solving this, we came across this 72. We came across 72 ohms. So that means what is this V2 by I1? V2 is nothing but the output side voltage, and this is nothing but the input current. So output and input current is nothing but the transfer impedance. Right? So Z21 is nothing but your transfer impedance. Which impedance? As it is the output to the input, output voltage to the input current. So it is nothing but a forward transfer impedance, or it is nothing but an open circuit forward transfer impedance. Z21, which is nothing but Z21, which we have defined already. So V2 by I1 is equal to Z2 by, so here it is there, Z21 is equal to V2 by I1 is equal to 72 ohms. So this is going to be our open circuit forward transfer impedance. Right. So now let us obtain the other two parameters. How to obtain the other two parameters? By considering the other port as open circuit. What is the other port here? Now here we have considered port 2 as the open circuit. Now let us consider the port 1 as the open circuit. Now When we consider the port 2 as the open circuit, if we consider the port 1 as the open circuit, so the circuit can be drawn as like this. The port 1 is open circuit, so I1 is going to be equal to 0. That's why, so here previous I1 is not equal to 0, that's why I have kept I1 as it is. But here I have considered the other current IY here. But I2 is going to be same. As the, now I1 is equal to 0 because the port 1 is open circuit. If port 1 is open circuit, the I1 is nothing but equal to 0. So that means from this circuit, what I am going to have is again applying the, again I am going to write the equations for V1 and V2. Again I am writing the expressions for V1 and V2. So when you are writing the expressions for V1 and V2, so now when we are writing the expression for V1 and V2, so now look at here. So here let us write the expressions for V2. So V2 is nothing but the voltage drop across the 240 ohm resistor. That is fine. The voltage drop across the 240 ohm resistor. But what is the current flowing through the 240 ohm resistor? We can't say because it is the not equal to I2 or not equal to IY. So that's why I have represented using the IX. The current flowing through the 240 ohm, I am considering it as the IX. So V2 is equal to 240 into IX. Now what could be the IX? Now again applying the current division rule. Again applying the current division rule. When we look from this side, this port, the second port, these two is going to be coming into the series. So now when these two are coming into the series, applying the current division rule, now from this one, Ix is equal to the source current, that is nothing but I2 into the opposite resistance, that is nothing but 120 ohm series with the 40 ohm. So 120 plus 40 is going to be 160 divided by the sum of the total resistance, that is 240 plus 40 plus 120 is going to become 400. So Ix is going to become 160 divided by 400 into I2. So let us say this is the equation number 2 and the previous one is equation number 1. Now again, like as we have done in the previous one, again substituting this I1, again substituting this I1, again substituting this equation number 1 in equation number 2. So if we substitute this equation number 1 in equation number 2, what we came across? So equation number 1 in equation number 2. So that means here, what is the, from equation number 1, we can come across the value of Ix. So what is the value of Ix from equation number 1? V2 by 240. So in equation number 2, instead of Ix, I am substituting V2 by 240. V2 by 240, which is equal to 160 divided by 400 into I2. So from this, I can write V2 by I2 is equal to so 240 into 160, 240 into 160, divided by 400. Now solving this, we can come across 96 ohms. So what is this V2 by I2? V2 by I2 is nothing but output voltage to the output current. It is nothing but the output impedance. Driving point impedance, or it is nothing but the open circuit output impedance, because it is the output voltage to the output current. Output voltage to the output current is nothing but the driving point output impedance, or it is nothing but the open circuit output impedance, or it is nothing but the driving point impedance or open circuit output impedance. So V2 by I2, what is the driving point impedance or the open circuit output impedance? Z22 is a term. So Z22 is equal to V2 by I2 is equal to 96 ohms. Right. So now Coming back to the second equation, that is, now let us write the equation for V1. Now look at from this port 1. So if you look at from this port, the V1 is nothing but the voltage drop across the 120 ohm resistor. So what is the current flowing through this 120 ohm resistor? It is nothing but IY. It is nothing but IY. IY is the current flowing through the 120 ohm resistor. So V1 is equal to 120 into IY. V1 is equal to 120 into IY. So let us say this is the equation number 3. Now let us apply the equation for IY. So when you are applying the equation for IY here, so IY is going to be equal to, so this is the IY, but here what is the source current? It is the current which is flowing towards this is I2, the source current I2 into opposite resistance. What is the opposite resistance? 240 ohm resistor. 240 ohm resistor. 240 divided by sum of the total resistances. Because if this is IY, obviously here also it is going to be IY. So this is going to be IY here. So this 2 is going to be in series here. So now, if you look at from this side, so IY is equal to, this is the IY, this is the IY, this is IY. IY is equal to the source current, that is the current entering towards this side is I2 into opposite resistance, that is 240 ohms, divided by sum of the total resistances. 240 plus 40 plus 120 is going to be equal to 400. Now again substituting this equation number 4 in equation number 3. What is equation number 4? IY is equal to 240 divided by 400 into I2. Now substituting this 4 in 3, what you are going to come across? So now let us see. V1 is equal to 120 into, what is IY? What is IY? IY is equal to 240 divided by 400 into I2. IY is equal to 240 divided by 400. 240 divided by 400 into I2. So now if I bring this I2 towards this side, I am going to have V1 divided by I2. V1 divided by I2. So which is going to be equal to this, if we solve this complete thing, we are come across 72 ohms. So 72 ohms here. So what is this V1 by I2? V1 by I2. That means the input voltage to the output current. So which is nothing but the transfer impedance. Which transfer impedance? Input voltage to the output current means reverse transfer impedance. So this is nothing but the V1 by I2, which is nothing. What is the reverse transfer impedance? Z12. Z12 is going to be equal to transfer impedance, or we can say it as the open circuit, because we are open circuiting the port 1. When the port 1 is open circuit, we are going to come across this V1 by I2 is equal to Z12, which is equal to V1 by I2 is equal to Z12 is equal to this open circuit reverse transfer impedance. Which is equal to 120 into 240 divided by 400, which is equal to 72 ohms. So this is how we are going to obtain the Z parameters. So now, if you want to write the matrix, the final square matrix, which is nothing but Z is equal to Z11 is nothing but 84 ohms, Z12 is nothing but 72 ohms, Z21 is nothing but 72 ohms, Z22 is equal to 96 ohms. So this is going to be nothing but our final impedance parameters, or we can say the open circuit impedance parameters or Z parameters. Thank you.